All right, so now we're going to talk about how to balance redox reactions. Balancing redox reactions is not like balancing any other reactions, um, just because they can get very messy and very complicated. So there's a specific set of steps to be able to balance a redox reaction when you see one. Um, so the first thing, there's these 7 steps that we're going to follow, but if I would add one step before we do any of this, maybe call it step 0, and that would be remove all spectator ions, and that's going to make your life easier if those are not present. So the best way to learn this is to just go through these examples by following the rules and explaining each step as we go. So in this first example, we have iron 3, so that is iron with a charge of 3, reacts with tin with a charge of 2, and it forms iron with a charge of 2 and tin with a charge of 4. Now, realistically, if this were an actual reaction taking place like in the lab, these would be solutions of iron 3 chloride with tin 2 nitrate, for example. The chlorides and the nitrates would be the spectators, and that's why they're not shown here. They're just kind of completely left off. So, now we start following steps. So step 1 is to divide the equation into half reactions. And when we say half reactions, what we're doing is we're combining the things that are alike. So iron forming iron, that would be one half reaction. It would look like this. Fe plus 3 forms Fe plus 2. That would be one half reaction. And the second one, then, of course, would be Sn plus 2 forming Sn plus 4. So that's step 1. Step 2, balance atoms other than H and O. Okay, well, there's no H's or O's present in any of these, so we can skip that. Step 3, balance oxygen. There's no oxygen, so we skip that. Step 4, balance hydrogen. Again, no hydrogen, so we skip that. Balancing the charge by adding electrons. Okay, so this is important. So in the first half reaction, the charge on the left is plus 3. The charge on the right is plus 2. Now, the charges do not need to be 0, but they must be equal. The left side must equal the right side. So the only way that we can balance that is by adding electrons. So I add 1 electron to this side. That makes both sides have a charge of plus 2, because the plus 3 less 1 is plus 2. Now we move on to the second reaction. Here I've got a plus 2 and a plus 4. So if I add electrons, 2 of them, to the right side, now both sides have the plus 2 charge overall. Okay, so next step, equalize the number of electrons gained and lost. So these two half reactions both will be added together. So the electron gain is the electrons that are being added to the reactant side. The electron loss are the electrons on the product side. Now they must be equal. So the only way to make them the same is to multiply the entire equation by some coefficient. So if I multiply this entire half reaction by 2, that means 2 electrons will be gained and 2 electrons will be lost. And then now at this point, I go ahead and add up the reactions for the overall reaction. F2Fe plus 3 added to tin with a charge of plus 2 forms 2Fe plus 2 plus tin with a charge of plus 4. And this would be our balanced redox equation. Now, granted, this first example was heavily simplified because it didn't have any spectator ions and didn't have a bunch of H's and O's to deal with. Now, a reaction like this is not entirely realistic, so let's move on to a more pragmatic example here. So in the next example, in an acid solution, dichromate. So dichromate is Cr2O7 with a minus 2 charge. So dichromate oxidizes iron 2 to become iron 3 and produces chromium-3. So those are the major players here. Again, spectators have been left off. So step 1, write the half reactions. So the first half reaction would be the Cr2O7 minus 2 becoming chromium-3. I'm actually going to center this a little bit because I'll be adding to both sides. So you need it in the middle. Okay, that's our first half reaction. The second half reaction is the iron with a charge of +2 becoming iron with a charge of +3. Okay, that's step 1. Step 2, balance atoms other than H and O. So when I look across here, the chromium, there's 2 chromiums here on the left side. So I'm going to need to fix that. So I'll go ahead and put a 2 here. And in the second half reaction, 1 iron and 1 iron. So those are fine. The next step, balance oxygen by adding water to the side that needs oxygen. So this unit is all about reactions that take place in solution, which means water is present. So if water is present, that means we can use water as a way to balance our oxygens. So if I add 7 waters to this side, that will give me enough oxygens to balance the oxygen count. So 7 waters to this side. In the second half reaction, there's no oxygen, so we skip that. The next step, balance hydrogen by adding H plus to the side that needs it. Okay, so I've got 7 waters. By adding 7 waters, I've now brought in 14 hydrogens. But the way to balance hydrogens in redox reactions is to write them as H plus, because H plus is readily available from water, but also a lot of these reactions are taking place in acidic environments where there's lots of H plus anyways. So that's where it's going to come from. So 14 H plus on the left side. Down here, no hydrogens, so we skip that. Step 5, balance the charge by adding electrons. Okay, so the total charge on the left side of this half reaction, 14 positives, 2 negatives. So the left side has a net charge of +2. On the right side of the arrow, we've got 2 chromium-3 ions, which means our total charge on the right side is +6. So to make +6 and +12 equal, we're going to add 6 electrons to that side. Okay, and for the second half reaction here, +2 ends up forming +3. I am going to need to add 1 electron here. Now both sides have the same charge. Okay, next step. Equalize the electrons, the number of electrons gained and lost. So since 6 electrons were gained and 1 electron was lost, I'm going to need to multiply this entire half reaction by 6. So after doing that, the 6 electrons on the right will cancel the 6 electrons on the left, and now we can write our final equation. 14 H plus Cr2O7 minus 2 plus 6 Fe plus 2 forms 2 chromium-3 plus 6 Fe plus 3 plus 7 water. And you can go back and you can rebalance and check everything, that the number of atoms of each element is the same on both sides and the total charge is the same on both sides. And now this is how you balance a redox reaction using the ion-electron method.